Good day, everybody. Uh, I'm Darren. I'm going to cover a paper today. This is the Edexcel Higher Maths pa paper 1HR. Since since for every Edex, Edexcel Maths paper there are two versions of the paper. There's paper 1H and paper 1HR because of different time zones. Anyways, I digress. But today we'll be covering this maths paper from January 2019. As you may know, this is a recording, so feel free to feel, feel free to pause or rewatch sections if you don't understand parts of this paper. And without further ado, let's start working on this paper. So it begins with this question 1, where you have to show that 1 and 2/3 plus 2 and 3/4 equals to 4 and 5/12. This should be a relatively easy question in terms of the paper and 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 shouldn't require much explaining, but let's get into it, shall we? So first of all, what you need to do with this is that you need to convert the fractions from this mixed form to a to an to an ir- to an improper fraction. Yes. So if you can, yes. So 1 and 2/3 equals to 5/3. 2 and 3/4 is 11/4, which equals to 20/12 plus 33/12. And as you can see in the last step, we made the denominators of both fractions equal. This was done by multiplying this fraction by 4 and the second one by 3. So you have 20/12 and 33/12, which make 53/12. And 53/12 can be broken down into 48/12 plus 5/12. And 48/12 is another way of saying 4. So this shows that 1 and 2/3 plus 2 and 3/4 equals to 4 and 5/12. Let's get to the next question. Wait, sorry, wrong page. Okay, question 2 of this question paper. There are 60 children in a club. In the club, the ratio of the number of girls to the number of boys is 3 to 1. 3/5 of the girls play a musical instrument, 4/5 of the boys play a musical instrument. What fraction of the 60 children play a musical instrument? Now, this is another question related to fractions, and well, compared to other questions, relatively simple as we're only at the beginning of the paper, but the way to solve this is for, first of all, find the number of boys and girls. So the ratio of boys and girls is 3 to 1. So the number of girls will be 3/4 times 60, which equals to 45, while the number of boys is 1/4 times 60, which equals to 15. The fraction here comes from this ratio over here, where if you have a ratio A to B, the amount of objects on each side of the ratio can be said to be A over A plus B times total number of things. So So all we did here is find the number of boys and girls as the ratio is 3 to 1. So obviously here you can also see that the ratio of girls is 3 more, the number of girls is 3 more than the number of boys. And and um and next we need to find the amount of girls and boys that play instruments. So the number of girls that play of instruments is 3 over 5, which is 3 over 5 times 45. And that gives us 27 girls that play instruments. While for boys, it's 4 over 5 times their number, 15, which equals to 12 boys playing musical instruments. So when you add these both together, you get 39 children that play an instrument. Alright, so far so good. Let's go on to the next question. So question 3. Here we have a triangle with given dimensions and named points. In the triangle PQR, S is the point on PR. The angle RSQ equals to 90. RQ is 14 centimeters, RS is 10 centimeters, and SP is 5 centimeters. Work out the length of PQ. So here we have a geometry question that will require a bit more solving. But this question does not require any sort of trigonometry, so this question is relatively easy compared to other geometry questions, as we have basically two right angle triangles stacked next to each other, which allows us to apply the Pythagorean theorem on this triangle. So to find out the length of PQ, first we find out the length of this x. To find the length of x, we apply the Pythagorean theorem. So x squared plus 10 squared will be equal to 14 squared, as a plus b, a squared plus b squared will be equal to hypotenuse squared. So on applying the Pythagorean theorem, we can rearrange this equation to have x as the to solve for x. So x squared plus 100 equals to 100 and not one no, 196. X x squared equals to 96, as 196 minus 100 would be 96, and therefore x would be the square root of 96, whatever that is on your calculator. Remember, both Edexcel papers allow calculators, so if there's anything that is difficult to calculate, feel free to use your calculator. And with this square root of 96, we can calculate the length of PQ. So PQ squared would be equal to PS squared plus SQ squared. So 5 squared plus square root of 96 squared. PQ squared can be said to be 25 plus 96, which makes 121. Therefore, PQ by squaring both sides equals to 11. Therefore, we have found the length of PQ, 11, 11 centimeters. Remember to put the measurement units at the end of your answer if all the given data also uses units. So the the inclusion of units might be worth a mark, and forgetting to add units might cost you a mark. So always remember to add units at the end of your answers if the question needs them or just mentions them. So yes, the answer to this question is 11 centimeters for the length PQ. Let's move on to question 4. Question 4 states that A, B, and 40 are four numbers. A is the smallest number and 40 is the greatest number. The range of the four numbers is 14 and the median of the four numbers is 30. Work out the value of A and the value of B. So this question merges statistics and algebra together and requires multiple steps to solve. First of all, let's use the range. Let's find the range of the four numbers. So the range of the four numbers is 14 as mentioned in this question. And using the range for for this for this number, we can find out the length the value of A. So so it says that A is the smallest number. And the range is the difference between the biggest number and the smallest number. Therefore, A equals to 40 minus the range, which equals to 40 minus 14, which equals to 26. Now we know that A is 26, so we have 26, 26, B, and 40. But we still don't know what B is yet. So now we need to figure out the value of B. We need to use the median to figure out the value of B. So we know that the median is 30, and that equals to 26 plus 26 plus B plus 40 over 4. As the median is a way of saying all of the numbers added together and divided by the number of numbers. So rearranging this equation to solve for B, we get 120 equals to 26 plus 26 plus 40 plus B. Therefore, 120 equals to therefore 120 equals to 120. Therefore, 120 equals to 92 plus B. Therefore, B equals to 120 minus 92, which gives us the answer B equals to 34. And here we have it. We have the answer of both A and B. So far, so good. All right, next question. Question 5. The Shanghai Maglev train takes 8 minutes to travel a distance of 30.5 kilometers. Work out the average speed of the train. Give your answer in kilometers per hour. Now, how we solve this is is firstly to find out the number of to, to find out how many hours 8 minutes can convert into. So 8 minutes divided by 60 equals to 2/15 of an hour. Since we need to convert this because we need to give our answer in kilometers per hour. So and the given value is a minute. So we must convert the minutes into hours. After we do that, we can use our calculator to calculate 30.5 kilometers, which is the distance, over 2/15, which is the time. As speed is distance over time. So since speed is distance over time, we use this to figure out the speed, the distance over the time. So if you put this into your calculator, you'd get the answer 228.75 kilometers per hour approximately. Yes, and yes, we have solved the question. This question is relatively simple, but it requires you to think. And you need to read the question carefully or else you might get the question wrong. Units are important, as I said earlier. Now on to the next question. The diagram shows the triangle PQR. In the diagram, all the angles are in degrees. So we know that the angles are not radians, which would simplify our calculations by some amount, unless you find radians easier. I don't know. Personally, I find degrees easier to work with than radians, but I digress. So in the diagram, we need to find the value of y, and we have to show clear algebraic working. The only the only information they have given you is that RP plus RQ are equal. So other than the angles of the degrees, we know that the triangle is an isosceles triangle, which obviously which obviously means that the bottom two angles, this one and this one, are the same. So 3x plus 10 equals to x plus 52. Since we know both of these angles are the same, we can rearrange the equation to solve for x. So 2x plus 10 equals to 52, 2x equals to 42, and therefore we find that x equals to 21 degrees. But this is not the angle. Next, we need to insert x into 3x plus 10, for example. And from this, we find that 3 times 21 plus 10 equals equals to 73. Let's check our answer of the other equation, x plus 52, where we get 21 plus 52, which is also equal to 73. Therefore, we have calculated the bottom two angles correctly, and since we know that they're equal. Now the only thing left to do is find y. To find y, we subtract the two bottom angles from 180, which is the total size of all angles in a triangle. So 180 degrees minus 73 degrees minus 73 degrees gives us 34 degrees. So there we have it. Y is 34 degrees. This For this question, we need to apply the principles of isosceles triangles and the fact and the you need to know that the bottom two angles of an isosceles triangle are equal, but otherwise this should be a relatively simple question and relatively straightforward. Now let's get on to the next question, shall we? So the diagram shows two water towers in Kuwait. The real height of Tower A is 187 meters, the real height of Tower B is 147 meters, and Ahmed makes a scale model of both towers. The height of Tower A on the scale model is 90 centimeters. Work out the height of Tower B on the scale model. Give your answer to the nearest centimeter. So from this, we can tell that it is a question about proportion proportionality and also and about things that are directly proportional. So we have the real towers and we have the models, which are shrunken by a certain scale factor. And also, one important thing to note is that we have to give the answer to the nearest centimeter. So, so we must round our answer up somehow. And we must round it correctly too, otherwise a mark may or may not be lost. So to solve this, we can first write down the equation for this question. So 187 is the real size, and that equals to 90 centi and that equals to 90 centimeters shrunken by a certain scale factor that we will call k. So in questions determining the the ratio or like the size of of a scale model or anything like that, you don't need to convert the units because if you use the same scale factor, it's it basically cancels out the need for units. So you can just write 187 and 90, despite them being meters and centimeters, to find the scale factor. And from this, using the calculator, we find that the scale factor is 0.481 something 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 something. Next, we need to find out the height of the scale factor of tower B. So we know that tower B is 147. Apologies. I seem to have mixed up the question. Sorry. Okay. Let's begin this question again. So using using scale factors, we can say that the height of the scale model equals to the height of the actual tower times a certain scale factor that has shrunken it to 90 centimeters. The units don't matter here, since the scale factor is simply just a number that doesn't have any large bearing. So from this we can find that the scale factor is 0.481 something according to your calculator. And next you should use that value on your calculator and multiply it by 147, which is the actual height of the other tower. And there you can find that the second scale factor would be 71 centimeters tall. So this question, sorry for the slip up earlier. This question this question applies the principles of scale factors and direct proportionality to a more realistic example. So with scale models and real towers, but but once you understand the principle, it would be quite straightforward as long as you are constant with your scale factors and your values. So the next question would be question 8, which shows two simultaneous equations, and we need to solve both of these simultaneous equations. And we need to show clear algebraic working. So this is a more direct kind of question where we directly solve for two values without having a worded problem or any kind of like call any kind of any kind of situation given. Here we just have two different equations, so 4x plus 2y equals to 9, x minus 4y is 9. So we will label these equations 1 and 2. And from equation 2 you can rearrange the equation to say x equals to 4y plus 9. And using this, we can we can substitute x in equation 1. So 4 times 4y plus 9 plus 2y equals to 9. Therefore, it can be rearranged as 16y plus 36 plus 2y plus 9. And 18y plus 36 equals to 9. Moving the terms to the right hand side, we get 18y equals to negative 27, and therefore y equals to negative 1.5. Now we need to do the same for x. So bring this to the top. For example, we use equation 1 to solve for x. So we know the value of y is negative 1.5. For x plus 2 negative 1.5 equals to 9. The next step is to rearrange this equation as to solve x. So 4x plus minus 3 equals to 9. 4x equals to 12, and therefore x equals to 3. All right, is this all good with you? So you just solve the simultaneous equation here. So x equals to 3 and y equals to negative 1 over 5, because used we used the method of we used substitution to figure out the value of x in terms of y. To first solve for y, which is negative 1.5, then using the value of y to solve for x. Next question. The next question is actually a three-part question. So we have a number here. We need to write this number in standard form. We need to write this number n as a product of its prime factors, and we need to show our working clearly. And lastly, we need to find out the largest factor of n is an odd number. So firstly, with part A, we simply we simply make sure that the left hand side value, or as we can say a, is less than 10, and with a times 10 to the power of n. So to convert this to standard form, we simply just say 4.8 times 10 to the power of 11 to 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 say this number as a number in standard form. So we need to increase the power of 10 by 2, as we are shifting the decimal points here by 2 digits. So here we have 4.8 times 10 to the power of 11. Next, we need to write n as a power of its prime factors. So with part B, it's easier to work with the original n instead of the standard form number we obtained in part A. So 480 times 10 to the power of 9. So firstly, 10 to the power of 9 can be split into 2 to the power of 9 times 5 to the power of 9. So you already have this part sorted for us. And next we need to find the prime factors of 480. So we know that 480 is 3 times 160, and 160 is 5 times 20. 5 times 5 times 2 to the power of 5, which is 32. So here we've divided 480 into its prime factors. In the test, you wouldn't try to figure out this quickly. You would have to think of what numbers can 480 divide fully into, and therefore use this to find the prime factors of 480. So since now we have the prime factors, we multiply them all together, and we merge the common terms. So we get so so 2 to the power of 5 and 2 to the power of 9 make 2 to the power of 14. As when you multiply two of the same number with different powers, you get the base number with the powers added together. So 9 plus 5 is 14. So 2 to the power of 5 times 2 to the power of 9 equals to 2 to the power of 14. Now you can multiply this by 3 as there are no like terms. And for 5, you get 5 to the power of 10. So this is the entire number prime factorized. And next we need to do part C, which is to find the largest factor of n that is an odd number. So let us make a new document and work out C. So we need to find out the largest factor of n, which is, if you don't remember, 480 times 10 to the power of 9, which is written as 4.8 times 10 to the power of 11 in standard form and can be factorized as 2 to the power of 14 times 3 times 5 to the power of 10. Now the way we solve this question is to divide this number is simply to divide this number by 2 to the power of 14. As 3 and 5 are both odd prime factors, so 3 times 5 to the power of 10 would be an odd number. So and 2 to the power of 14 would be the biggest would would be an even factor, would be and 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 dividing 4.8 times 10 to the power of 11 by 2 to the power of 14, we get 3 times 5 to the power of 10 as mentioned before. And if you put that into your calculator, you get 29,296,875, which is a very large number. And according to this question's answer, and the largest odd factor of 4.8 times 10 to the power of 11. So that out of the way, let's get into the next question. So here we have question 10, another geometry question. So here we have a shape, which is a region between two semicircles, and is shaded in here as shown. The diameter of the outer semicircle is 12 centimeters, while the shape has a constant thickness of 2 centimeters. Calculate the area of the shape and give your answer to a multiple of pi. So to figure out this, first we should find out we should find out we should find the circumference of this no the rate no the area of this outer circle, if an entire circle with diameter of 12, which means a radius of 6, as the radius is half of the diameter. So to find the area of the bigger circle that extends here, we calculate pi times 6 squared, which is equals to 36 pi. Leave it as a multiple of pi because this question states that you just need to leave the answer as a multiple of pi. So avoid further complicating your question and just simply leave your answer in the simplest form until the end. And at the end, you should convert it to the form that the question asks for. For example, here we don't need to convert it to well any form as it's a multiple of pi already. So to the next part of the question, we need to figure out the area of this smaller circle contained inside this bigger full circle. So for this circle, the radius would be 6, which is the radius here, minus 2, as the outer circle has a constant thickness of 2 centimeters, so the inner circle would have a radius 2 centimeters smaller than the radius of the outer circle. So 6 minus 2 equals to 4, and the inner circle with a radius of 4 would be calculated with pi times 4 squared, which equals to 16 pi. And to find the area of this donut shape, we minus 36 from 16 pi, from which we get 20 pi. However, we only need half of the circle, as this is a semicircle, so we need to find out the area of the semicircle, which is 20 pi divided by 2, which gives us the answer 10 pi for the area of the semicircle. So far, so good. So now we go on to question 11. There are 12 boys and 8 girls in a class. The boys and girls have the same coins. The mean number of coins the boys have is 5.5. The girls have a total of 18 coins. Work out the mean number of coins the 20 children have. So, the mean number of coins the children have is 5.5. And the girls have a total of 18 coins. So first of all, since we know the number of coins the girls have, we need to figure out the number of coins that the boys have. The mean number is 5.5 per boy. And we need to multiply this by the number of boys, which is 12, which gives us a total of 66 coins between the boys. The total number of coins is 66, the coins the boys have, plus 18, the coins the girls have, which give us, well, it gives us 84. And to figure out the mean number of coins the 20 children have, we divide 84, the number of coins, by 20, the number of children. So from this we get 4.2 coins per child. And that's the question. Moving on to the next question, we have question 12, where we have the first four terms of a sequence of fractions. The 1 over 1, 2 over 3, 3 over 5, 4 over 7. The numerators of the fractions form the series of whole numbers 1, 2, 3, 4. The denominators of the fractions form the sequence of odd numbers 1, 3, 5, 7. Write down an equation in terms of n for the nth term of this series of fractions. And for part B, we need to use algebra to prove that when the square of any odd number is divided by 4, the remainder is 1. So So for part A, which is 2 marks, we firstly we just need to write the expression for the nth terms of this sequence of fractions. So un equals to the sequence for the numerators and the sequence for the denominators. So for whole numbers 1, 2, 3, 4, you just write n as when n equals to 1, un equals to 1, and so on and so forth. So far so good. Well, for the denominators, for odd numbers are basically even numbers minus or plus 1. And from here, it can be seen that the odd numbers are even numbers minus 1. So, because, for example, 1 is 2 minus 1, with n being 1 as the first number in the sequence. For n equals to 2, the denominator is 3, which is 2 times 2 minus 1. And the denominator for term 3 is 5. So 2 times 5 minus 1 equals to 5. So here we have a here we have a sequence. Here we have a formula for the sequence of fractions. And now we need to use algebra to figure out to prove something. To prove that when the square of any odd number is divided by 4, the remainder is 1. So the square of an odd number would be 2n minus 1, an odd number to the power of 2 squared. And this equation can be written as 4n squared minus 4n plus 1. And when you divide the expanded version of this equation by 4, you get n squared minus n plus 1 over 4. And 1 over 4 is another way of saying remainder of 1. As 1 would be 1 would be remainder of 4, which is in the thing, which means that it's a multiple of 4. So any fractions would represent remainder of this number when divided by this bigger number. So this question relies on the use of of series and proofs. Proof by proof by algebra, the which is one form of well algebraic proof. The next question uh sorry, that's the mark scheme. Question 13 is a calculus question. Here we need to find dy over dx, and we need to find the two turning points of curve C. So from this, firstly we just for the derivative dy over dx, we just need to apply the rule of derivatives to this to each term in this equation, excluding the constant term which isn't included in the derivative. So the derivative would be 3x squared minus 2x minus 8. Since the derivative of x cubed equals to 3x squared, as well, to recap, the the rule is that the derivative of something equals to equals to a n x to the power of n minus 1 if a term can be written as a x to the power of n. So for derivatives, to recap, you just multiply the you just multiply x by the power n, and you take away 1 from the power, so n minus 1. So x cubed would have the derivative 3x squared, and negative x squared will have the derivative negative 2x, and so on and so forth. And now we need to find the turning points of this equation. So turning points are basically just stationary points where the gradient is 0. So so basically the t- so basically with a graph, for example, probably not this. I'm not sure if this graph looks like this, but for example, a graph's turning points would be here and here at the vertex of each of these curves, where the tangent meets it at a gradient of 0, i.e. a straight line. So the derivative of an equation is an equation for its gradient. And using and since the gradient equals to 0, to find the two turning points, we can we can solve 3x squared minus 2x minus 8 equals to 0. So so to f- so next we should factorize this equation to find the two turning points. To factorize this to f- to factorize this with to factorize an equation with a with a with a coefficient at for the x squared value, we it's a little more complex. So we know that the two the two the, the so we so the two constant terms in the factorization need to add up to negative 2, and they need to multiply to negative 24, which is negative 8 times 3. So we need to so from this so so we need to find two numbers that add to negative 2 and multiply to negative 24, which conveniently are negative 6 and 4. So this allows us to write the equation as 3x squared minus 6x plus 4x equals to 8, which is another way to say negative 2x. But it makes it easier to factorize. So next you split the equation down the middle, and you factorize each side of the equation. So this side makes 3x squared minus 2x, which makes 3x minus x times x minus 2. And this half, 4x minus 8, factorized as 4 times x minus 2. So you can see here that both of these equations have the common coefficient of x minus 2. One of the brackets for the factorization of 3x squared minus 2x minus 8 equals to 0 would be x minus 2, while the other one would be the two other coefficients added together. So 3x plus 4. So here we have the factorized equation, and from this we can find that x equals to 2 and x equals to -3/4, which gives us the x-coordinates of the two turning points of the question, therefore solving part B of this question. I'm sorry if that sounded a little complex, and if the explanation was not very clear. If the explanation was not very clear, or if you found it a bit complex, feel free to ask me about this in the Discord server. Thank you. So, moving on to question 14. Oh, never mind, never mind, never mind. Never mind, there's a part C to this question paper. So, to solve part C of this question paper, we need to show that the x-axis is tangent to the curve C. So, the thing about these stationary points with gradient equals to 0 and with the straight lines that are the tangents of set points. Well, this question states that the x-axis would be the tangent of one of these points, or even both of these points. So we would have a curve of something like this, or something like this, with one of the points touching the x-axis at its turning point. To solve this, we must substitute the two turning points, which are x equals to -3/4 and x equals to 2 from the previous question, and substitute them in to the equation of the graph. So the equation of the graph is y equals to x squared, x cubed minus x squared minus 8x plus 12. So you substitute both of these x values into this. So for -3/4, we can solve it like this. And you can solve this equation directly using your calculator. So this equation gives you 17.01562 probably something something something. So with the point 3, -3/4, the the um the tangent to this point is not the x-axis. So now we must substitute the other value, x equals to 2. So 2 squared minus 2, no, 2 cubed minus 2 squared minus 8 times 2 plus 12, which equals to 0. And if y equals to 0, it is another way to say the x-axis. So we can prove that at x equals to 2, the equation passes the equation has tangent at the x-axis, or y equals to 0. So here we have proven that the x-axis is a tangent to one of the points of curve C, which solves said question. Now let's move on to question 14, this time for real. Here we have a cumulative frequency graph, which gives us information of the values in thousands of euros of 120 apartments in 2015. So, so with this graph, we need to find, well, multiple things. The first part of this question requires us to find an estimate for the number of these apartments with a value of 80,000 euros or less in 2015. Now, what we need to do is 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 to is to go to the x-axis, which is the value in thousands of euros. So here we can find 80,000 euros or 80,000 euros. So we draw a straight line from this point on the x-axis to the, well, a straight line. So in the exam using a ruler, but on here maybe using the line tool. So 80,000 euros from the x-axis to a point on the graph. And we need to find the cumulative frequency for 80 euros. So a cumulative frequency for 80 euros would be to draw a line from the desired point at the value for 80 euros, 80,000 euros, and drawing it all the way to the y-axis. So here we have the cumulative frequency for so we have the cumulative frequency for the value of apartments with 80,000 euros or less. So we've solved this question. Now all we need to do is to find the value that this is. So this value would be 97. So an estimate for the number of apartments below 80,000 euros or at 80,000 euros would be 97 out of these 120. For part B, we are given a table where well, the table states the value of of um of the apartments in thousands of euros and the cumulative frequency of said apartments. So here we have the table and here we have the graph. So what we need to do is plot all these points onto the graph. So firstly, the value in thousands of euros, we find the median value for each of these boxes. So the median value of the median value between 0 and 20 is 10. The median value between, well, 20 and 40 is 30, 50, 70, 90, and 110. So all we need to do is to um is to plot these points on these x values. So with with the midpoints of each value. So 10, so because the median value of each of these cumulative frequency groups would give us a the median values of these cumulative frequency groups would be a very good estimate of the average of these cumulative frequency groups. So that's why they are used. So so 10 and 0, we plot it here. 30 and 15, we plot it we plot it here. For 50 and 44, we plot it at 40, 44 here. For 70 and 85, we plot it 80, 80, 80 to 80, 85. 90 and 102 would be up here, while 110 and 120 would go all the way to the top, right here. So now we've plotted all the points, we should draw a graph, draw a line connecting these points, and that would be the cumulative frequency graph. So like this, and followed by this, and this, and this. So there we have it. We have the cumulative frequency graph for this new set of values. The final part The final part of this question requires both this new cumulative frequency graph and the original graph given on the exam paper. So the last question is to well, find an estimate for the increase in median value for these apartments from 2015 to 2018. So what we need to do is to first of all find the median cumulative frequency, which is 60, right between 0 and 120. So you draw a line from 60 to, well, both of these graphs, and we draw two lines descending from from each of these graphs to the x-axis, where we determine the difference between the mean value of housing from the median value of housing from 2015 to 2018. Mean and median, two different things. So for the original graph, this thinner one right here, the value the median value in thousands of euros is 54, while the median value of new apartments is, on this graph, 50, 1, 2, 3, 4, 5. Actually, the median of this is 52, not 54. No, it's 54. The median value of an apartment in 2018 would be, well, let us see, 54, 50, 57. So we have 57 and 54 as our median values. And from this, the estimated increase is 3,000 euros. So there we have it. We can use the cumulative frequency graph to find the increase in median values for these apartments from 2015 to 2018. Sorry if this one's also a bit unclear. Any questions will be directed in the Discord. So let's move on to question 15. Sorry, that's the answer sheet. Question 15. Simplify, simplify 3x squared y to the power of 5, all of this to the power of 4. So, and also we need to expand and simplify this, and factorize this, and simplify this, which makes this a long 4-part question. And we shall tackle this question part by part. So part A, we need to simplify 3x squared y to the power of 5 to the power of 4. So to simplify this, we just simply get 3 to the power of 4 times x squared to the power of 4 times y to the power of 5 to the power of 4. As the power of 4 outside of the brackets would mean each of these terms are raised to the power of 4. So here we have 81 x to the power of 8 and y to the power of 20. Since if you have x to the power of a to the power of b, you basically have x to the power of a times b. So 2 times 4 is 8, 5 times 4 is 20. You should remember this from your times tables from when you were younger. Now for part B of this question, we need to expand and simplify 4n, n minus 3, n plus 5. So with 3, so this one will be a bit more complex. So first of all, we need to expand and simplify this, then expand and simplify whatever this is and this. So 4n, n minus 3 equals to 4n squared minus 12. Therefore, the question can be simplified to 4n squared minus 12 n plus 5. Multiplying both of these brackets together with, and expanding them, you get 4n to the power of 3 plus 20n squared minus 12n squared. No, actually, 12n minus 12n squared. Yes, squared, as this is an n, and this is also an n. I forgot to add earlier. I am sorry about this. And the last term is negative 60n. This can be simplified to 4n cubed minus 8n squared plus minus 60n. Apologies for the mistake. And here you have it, simplified. Part C of this question requires you to factorize 4c squared minus 9d squared. So what you will notice from this is that this equation only has 2 terms, but they're both squared. As a result, you can say that this is a difference of 2 squares. Which means that you have a plus b and a minus b, where the answer is a squared minus b squared, which is in the form of this equation here. So 4c squared minus 9d squared would factorize into, 2c squared plus 3d squared, 2c plus 3d, 2c minus 3d. So we're using this principle here, where we get the square roots of each of these terms and substitute them with a and b. So far so good. Now we move now we move on to the last question in this group of questions. In this group of questions, well, question 15, sub question D, where we need to fully simplify this fraction. Usually, simplifying fractions is often not as simple as simplifying, well, whole numbers, mainly due to, main, well, sometimes it's like this. So what we need to do is to factorize the denominator. This denominator can be factorized as x 4 minus x. By factorize, we mean we find the common factor and we remove it to outside of a bracket. And with this, inside of a bracket. Now next, we need to factorize this numerator above. And since this fraction can be simplified, we know that one of the one of the one of the parts of the numerator would be 4 minus one of the factors of the numerator will be 4 minus x. We just need to find the numerator's other factor. We need to find a way to get to add to 7, to add to negative 7 and multiply to 12. Since we have negative x on this side and the x is positive on the numerator in question, the x squared is positive on the numerator of question D, we have negative x on this side as well. To get negative 7x, we simply find what 7 can add to. So obviously 4 plus 3 makes 7, and 12 is just 4 times 3. So here we have it. We have the factorized equation for this fraction, and now we just remove 4 minus x from both sides, which gives us 3 minus x over x. And that is the answer for part D of question 15. Going on to question 16, which is, we have which is a long way, which is still quite a long way from the end of this paper. We have question 16, where there are 12 beads in a bag. 7 of them are red, 3 of them are green, 2 of them are yellow. Lucy takes one of them at random and keeps it. Then Julian takes one of them at random and keeps it. Now we need to find out the probability that they each take a yellow bead and the probability that the beads they take are not of the same color. So what we can do, firstly, for the first part of the question, we know that there are so the probability of Lucy taking yellow bead is 2 out of 12, as there are 2 yellow beads in the bag and there are 12 total beads. However, Lucy keeps it, which means for Julian there's one less yellow bead and one less bead in total. So the chance of Julian taking a yellow bead at random is 1 over 11, as there's only one yellow bead in the bag and only 11 beads left in the bag, as one of them has already been taken. So here we get 2 over 132, which can be simplified to 1 over 66, which is not a very high chance, but here's the answer. 1 over 66. For part B, to work out the probability that the beads are not the same color, we work out the probability that the beads are same color and take that away from 1. So 1 minus, so the probability of both beads being yellow is as above, 2 over 12 times 1 over 11. Take away the chance that both beads taken are red, so 7 red beads over 12 total beads times 6 red beads left after 1 red bead removed over 11 beads with 1 bead removed. And then minus the chance that both of the beads are green, so the same principle. 3 green beads over 12 beads minus 2 green beads left after 1 removed over 11 beads left. From this, we can convert all of these to fractions of anything over 132, as 12 times 11 is 132, which would be the lowest common denominator for each of these fractions. So 2 over 12 times 1 over 11 would make 2 over 132. 7 over 12 times 6 over 11 will be 42 over 132. 3 over 12 minus 2 over 11 would make 6 over 132. And if you subtract all of these from 132 over 132, you up you get you get the answer you get is 82% is 82 over 132 chance that the beads are not of the same color, which equals to 41 over 66 chance. Any question? Any questions? Right. This is a video lecture. If you have any questions, direct them in the Discord. Thank you very much. So after we figured out question 16 out, we can move to question 17, where we have a solid sphere and a solid cylinder. They really love to ask this kind of question apparently. I've seen a lot of variations on this question. So what we need to do is find the radius to find an expression for k in terms of r. So the question states that the radius of the sphere is r, the radius of the cylinder is also r, so we have the same radius for the sphere and the cylinder. And the height of the cylinder is 2r centimeters. The total surface area of the cylinder is k times pi centimeters squared. And for part A, we need to find the expression for k in terms of r. And for part B of this question, where, well, there is a part B, we need to we have to show that the ratio total surface area of the cylinder to total surface area of the sphere is the same ratio as volume of the cylinder to volume of the sphere. So this is a two-part geometry question. This, which is actually quite common, but is also one of the more complex types of questions. So that's why they like to put it at the end of papers, or, well, near the end, not the end. We still have a couple questions to go. So to find an expression of k in terms of r, we just we need to we need to We know that the total surface area of the cylinder is k pi centimeters squared. So the total surface area of a cylinder would be the surface area of the top circle, well, a cross section multiplied twice for top and bottom, and the curved surface area of the cylinder. So the total surface area of this cylinder would be 2 pi r squared, as top circle pi r squared, bottom circle pi r squared times 2 pi r squared. And to determine the curved surface area, we need the circumference times the height. So the circumference is 2 pi r, and the height is 2r. And that's how you determine the surface area of a cylinder. So 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 um so now we have to simplify this so that we can answer the question at hand. So 2 pi r squared plus 2 pi r times 2r equals to 4 pi r squared equals to 6 pi r squared. And therefore we can write this as 6r squared times pi. So k equals to 6r squared, as the surface area of the cylinder is k pi centimeters. So 6r squared equals to k. And for part B, we need to show that the ratio of the total surface area of the cylinder to the total surface area of the sphere is the same ratio as the volume of the cylinder to the volume of the sphere. So what we need to do for part B of this question is surface area of the cylinder to the surface area of the sphere. We need to find this out. So the surface area of the cylinder is the surface area of the cylinder and the surface area of the sphere are equal to the volume of the cylinder and the volume of the sphere. So the volume of the cylinder would be would be would be 2 pi r squared. No, actually, pi r squared times 2r to the ratio of the volume of the sphere, which will be 4/3 pi r cubed, which gives us surface area of the cylinder to surface area of the sphere equals to 2 pi r cubed to the power to 4 over 3 pi r cubed. And next, we know that the surface area of the cylinder is 6 pi r cubed, while the surface area of the sphere, well, to determine the surface area of a sphere, the equation is 4 pi r cubed, which equals to 2 pi r cubed to the ratio of 4 over 3 pi r cubed. So we can just remove the pi and the r's for this, as this is a ratio, so we only would require numbers. So 6 to 4 equals to 2 to 4 over 3. And that's true, because if you multiplied both sides of this ratio by 3, you get 6 to the power 6 4 equals to 6 4. Therefore, we've just proved that the ratio of the total surface area of the cylinder to the total surface area of the sphere is the same ratio as the volume of the cylinder to the volume of the sphere. Question 18. Show that the square root of 8 over the square root of 8 minus 2 can be written in the form n plus square root of n, where n is an integer. Show you're working clearly. And this question is worth 3 marks. So switching to MS Paint, we would calculate this by first of all rationalizing the denominator. So you multiply both the numerator and the denominator by square root of 8 plus 2, square root of 8 plus 2. So you'd get square root of 8 plus square root of 8 times square root of 8 plus 2 over square root of 8 minus 2 times square root of 8 plus 2. The reason for this is to not change the value of the fraction, but also make the denominator a whole number. So here we have 8 plus 2 and 2, 2, 2 root 8 for the numerator, and for the denominator we have 8 plus 2, 2 square root 8 minus 2 square root 8 minus 4. And we can cancel out the square roots because they add and subtract, so they basically amount to 0. So what this can be written as is 8 plus 2 root 8 over 4, as 8 minus 4 is 4. And then you can simplify the numerator by saying 8 plus 4 root 2, as you can as 8 is 4 times 2 and 4 is root 4 is 2, so 2 times 2 gives you 4, and remain with root 2 remaining. And you can say that this is all over 4. So we can divide both terms of the numerator by 4. So 8 divided by 4 is 2, while 4 root 2 divided by 4 is root 2. So 2 plus root 2, which is in the form of n plus root n. Therefore, we've just solved our question. This is probably one of the more complex questions, although it's logical that it's more complex because it's near the end of the paper, where the more complex topics and like the more and the ones that require more problem solving are tested. On to question 19, which I've already pasted onto this MS Paint document, where B, C, D, and E are points on a triangle. AB is a tangent to B at the circle, and AB is parallel to ED. Angle ABE equals to 73 degrees. Work out the size of angle DCE, and you have to give a reason for each stage of your working. So this question requires the circle rules, which is obviously a higher concept, at like a higher maths concept, which is personally one of my least favorites, but the questions about the circle rules often require large amounts of recall and use of an application of knowledge on an unseen diagram. So with this, we can so first of all, what we know is that ABE equals to BDE due to the alternate segment problem. Theorem. ABE equals to BDE because with because um because of the alternate segment theorem, which states that which states that which states that if like one of the angles which states that this angle here, A, is the same as this angle here, which is the same angle A. So this is what the alternate segment theorem states. Now next, ABE is equal to DEB as well. So this is also 73 degrees. The reason why? Because ABE and DEB are alternate angles. So this is 73 degrees, this is 73 degrees. And now all we need to find is this angle here, which is 180 degrees minus 73 degrees minus 73 degrees because of well, the size of angles in a triangle. So the bottom angle is 34 degrees since all the angles in a triangle add up to 180. Now we have to use another circle rule. One last circle rule to figure out the angle DCE. The rule is that the well, angles on a same segment are equal, which means that ABE equals to DCE because they both come from the segment DE. Not AB, DBE. DBE. DBE and DCE are equal because they both stem from the segment DE. And as a result, angle DCE equals to 34 degrees. Which gives us the answer to this question. Sorry if this one was a bit confusing. Circle the circle rules are not as easy to explain. And on to the next question. Here we go, question 20. Here we have a cube. A, B, C, D, E, F, G, H. M is the midpoint of the edge G and H. We have to find the size of the find the size of the angle between line MA and plane ABCD. And we need to give our answer to one decimal place. So we should first draw which angle we need to figure out. So M to A. So M to A. So we need to find out the angle between this line and the plane, which would look like this. What we need to do for this question is to add another point to our cube. Point N, let's just call it, which is the midpoint between B and C. And M and N are, well, they can be connected by a straight line. And as a result, we can draw a line from A to N, and we have a right angle triangle. Let's, well, And also and after this we should and let us have each side of the cube being 2a units long. So m to n is 2a, 2a, 2a. Yeah, so here we assume that all of the sides of the cube have length 2a. This is an arbitrary number that we can assign to the length of a cube to make solving easier. So after we've drawn a triangle but with MA as its hypotenuse, we can use trigonometric rules, or well actually you can also use the Pythagorean theorem if you can to find out the length of different sides. So first of all, let's find the length of AN. So AN, here we have another triangle that is also a right angle triangle where we have 2A on one side, A on the other. So to find the length of AN, we use the Pythagorean theorem, AN squared equals to 2A square all this plus A squared to find the length of AN here. The answer to this would be AN squared equals to 5A squared. Therefore, AN is the square root of 5A squared long. So now we have the length of the height and the opposite and the adjacent. Now we only need to find the length of we don't even need to find the length of the hypotenuse to solve for the angle MAN. So the angle MAN, using trigonometry, the tangent of angle MAN would be opposite over adjacent, which equals to 2A over the square root of 5A squared. So, and then to calculate the size of this of of this angle, we factorize out the a. So 2a over a square root 5 can be factorized as 2 over square root 5. And the last thing we need to do is, using our calculator, find the arctan of 2 over square root of 5. This should yield you 41.8 degrees, which is the size of this angle here. Understood? If not, then ask any questions in the Discord. This is a recording, and it's a reference material that you can use. On to question 21. Here's a triangle X, Y, Z. The perimeter of the triangle is k centimeters. Given that x equals to y minus 1, find the value of k and show you're working clearly. For this question, we need to use the cosine rule. Well, the cosine rule, which states that, x squared equals to y squared plus z squared, lowercase z squared, minus 2yz cosine times cosine of x degrees. So since we know that z is 5 and x equals to y minus 1, we can substitute the x with y minus 1, and we substitute the z with 5. So 5 squared, which is 25, minus 2y 5 times cosine 60. What we do next is we, well, factorize this equation and and so we can simplify it. So y minus 1 squared can be written as y squared minus 2y plus 1, and which equals to y squared plus 25 minus 10 10y times cosine 60. And if you remember the trigonometric identities, cosine 60 is equals to 1/2. So we can write this as y squared minus 2y plus 1 equals to y squared plus 25 minus 5y, since half of negative minus 10y is minus 5y. What we can do with this is, first of all, remove the y squared from both sides, because you can. Like, you can cancel out like terms to simplify your equation. And now we can just rearrange the equation. So 3y plus 1 equals to 3y plus 1 equals to 25. 3y equals to 24. And y equals to 8. Therefore, we have the value for y, which is one of the sides. So 8 centimeters. And also, since x is y minus 1, so this side would be 7 centimeters. After you found all the lengths of all three sides, you add them together to get the perimeter of the triangle. And there you have it. The perimeter of a triangle found using the cosine rule. This takes multiple steps, but in the end, if you calculate all this correctly, it is very rewarding. Now, on to question 22, the penultimate question of this paper. ABCDEF is a regular hexagon. ABX and DCX are straight lines, and the vector of A to B and the vector of B to C can be written as A and B respectively. And we have to find the vector E to X in terms of A and B. Give your answer in the simplest form possible. So what we can do is chart our journey. So so if you know, so vectors can be written as the sum of each of their parts. So from E to X, you can first go from E to D. Then you can go from from D to C, which, as you can see here, can be divided into two parts. And then the last section will be from C to X. So first of all, E to D. We know that A to B is A and B to C is B. So the first part of this, so E to D is A. Since this vector and this vector are virtually the same, so E to D can be written as A. Next, we need to write D to C. which which has to be written in two parts because a vector for this does not exist in the question. So B to C is B. The like the direction of D to the midpoint of the hexagon is basically B backwards. Since B is this way, D to the midpoint of the hexagon is this way. So this is negative B. And later on, C, actually not even the midpoint of the hexagon. You can you can actually just you so basically you can say D to here is negative B like this, and from this from here to C is the same as A. So D to C is negative B plus A, or A minus B. For C to X, it is actually the same vector. Where you go from C to B, then B to X. C to B is negative C to B plus B to X. C to B is basically negative B, and B to X is basically A. Yeah, since it says, yeah, so B up here, A this way. So therefore, EX equals to A plus A minus B plus A minus B, which equals to 3A minus 2B. This is the way you can write vector EX in terms of A and B. So for vector questions, you can basically break up the question into smaller chunks. What this means is well, to break it up into small chunks is to basically break up one vector into multiple steps. So E to D, D to C, C to X as individual parts of the vector E to X. And you can break these down into smaller steps, such as D to C being D to this point here, which I'll label, well, actually, whatever. D to this point and this point to C is another way of saying D to C. And the same and a similar things can be said for C to X. Now for the last question. Question 23. The function f is defined as f of x, the root of x cubed plus the root of k, no, x squared plus the root of k squared over x. And for x, which is for x is greater than 0, and where k is a positive number. Here we need to find the value of p for which f the inverse of x of p equals to k. And for part B, we are given another function g, which is g of x equals to x squared for x is greater than 0. And given that g of f of a is k for k is greater than 1, find an expression for a in terms of k. This is quite a mouthful and, well, fitting for a final question on this paper. Let us let us let us solve this question. So first of all, to find the value of p for which the inverse of f of x of p equals to k, first of all, we need to find the inverse function of f. And what we need to do for this is to first of all uh, state y equals to square root x squared plus k squared over x. And we can factor x onto the left hand side, and you can square both sides to get rid of the square root on the right hand side. And now what we need to do is to minus is first of all, we can write this as x squared and y squared, and we can minus x squared from the right hand side and move it to the left hand side. So this equation can be factorized as x squared y squared minus 1 equals to k. Uh, what we do next is we uh, what we do next is divide the right hand side by y squared minus 1. And this makes it easier for us to flip the x and y variables to solve for the inverse of this function. And to solve for the inverse, we need to find y in terms of x. So y equals to, well, k squared, k squared, k squared, k squared. So y equals to k over square root x minus 1, x squared minus 1. So so this is the inverse function. So this is f of negative 1 of whatever. So now f of negative 1 of p equals to k. And that equals to k over square root p squared minus 1. The only way that k can be, the only way that k can be equal to k over p squared minus 1 would be k equals to k over 1. So therefore, the square root of p squared minus 1 equals to 1. And also that means p squared minus 1 is 1, since if you square 1, it's still 1. So p squared is equal to 2, and therefore p equals to the square root of 2. I'll do that if it makes the last part of the question more visible. Okay, moving forward. The last part of this question, so it states that given g of f of a equals to k is k is greater than 1, find an expression for a in terms of k. So what we need to do in this last question is is g of f of a equals to, well, we need to, the function f with a instead of the function f squared, as this is how composite functions work, and this equals to k. And now we square the fraction like this, and we solve for this equation by 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 rearranging this equation for a in terms of k. So ka squared a squared And the next step we can do is state that is the next step we can do is write this as ka squared minus a squared equals to k squared, which gives us a squared k minus 1 equals to k squared. A squared equals to k squared over k minus 1. And therefore a equals to k over square root k minus 1. And that's the end of this question and the end of this paper. I'll review the mark scheme right now. So the mark scheme looks like this. So question 1 is 5 over 3 plus 11. So here is the mark scheme for this paper. Pause or slow this video down if you want to read the mark scheme. Actually, I will scroll through it again so you can pause at any point you want. And that's all for today. Thank you all for watching if you decide to watch this replay of the working out of this paper. Thank you very much.